The U.S. Army Corps of Engineers has been working on an initiative called Engineering with Nature. It all started in 2010. And this is the EWN Podcast. EWN is developing and implementing nature-based solutions for water and infrastructure projects. It's bringing together a growing international community of scientists, engineers, and researchers from all kinds of disciplines that are committed to harnessing the power of nature to solve problems. The EWN Podcast tells their stories. Now here's your host, Sarah Thorne of Decision Partners.
Imagine if brilliant scientists and engineers could figure out how to use natural materials like silt and clay dredged from waterways to make 3D printed structures like reefs and root configurations to restore habitat and protect coastal shorelines. And imagine if they used nature-inspired designs to create these 3D printed structures. What are the possibilities and what's the potential for nature-inspired 3D printing? That's what we're talking about today. So, welcome to Season 7, Episode 6. I'm here with my U.S. Army Corps of Engineers colleagues, Al Kennedy, Burton Suedel, and Andrew McQueen. And we're talking about the literally fantastic 3D printing workshop that we hosted in February to explore the potential of nature-inspired 3D printing. What was accomplished and what's next? So Al's a research biologist in the environmental lab at ERDC, the Engineer Research Development Center. He joined us in Season 5, Episode 1, to talk about how he and his colleagues in the Geotechnical Structures Lab, the Coastal Hydraulics Lab, and the Construction Engineering Research Lab at ERDC were coming together to begin to explore creating innovative solutions using 3D printing at both small and larger scales. So welcome back, Al.
Hi, thanks, Sarah. Our thinking has certainly come a long way since we last taped the show in November of 2022. Look forward to talking about what we've learned and what's up next.
A really significant progress, I'd say. Burton is a regular co-host on the EWN podcast and a research biologist in the environmental lab at ERDC. Burton was also part of the conversation on that Season 5 episode. So great to have you back, Burton.
Hi, Sarah. It's great to be back. And there's so much for us to talk about coming out of the workshop. I'm really looking forward to a great discussion today.
And Andrew is also a research biologist in the environmental lab and a familiar voice on the podcast. He joined us in Season 6, Episode 3, where we were talking with Joe Christo of Stone Living Lab about the application of nature-based solutions in urban settings. Welcome back, Andrew.
Yeah, happy to be here and to continue chatting along this idea of new technologies that help us achieve nature-based and nature-inspired solutions.
Great. We're excited about this episode. We've included several others who participated in the February workshop, and we'll introduce them throughout the show. So let's start our conversation by putting 3D printing for nature-inspired infrastructure in perspective here. Al, can you talk a bit about the big picture?
Thanks, Sarah. Well, the big picture here is really that there's so many pressing national issues driving our research and development objectives and innovations. It's ranging from coastal resilience challenges in the face of climate change, the need to restore and create new habitat, address outdated and aging infrastructure, and we really need to pursue more sustainable use of local building materials. We believe it's possible to improve the civil works mission delivery by leveraging emerging and disruptive technology innovations such as 3D printing.
It's pretty exciting. Burton, talk a little bit about what the context is for the Corps broadly and the Engineering with Nature program specifically.
Well, Sarah, if we think about the Corps broadly, we think about the Corps' navigation mission, particularly related to sediment dredge from our federal navigation channels on an annual basis. We typically dredge more than 200 million cubic yards every year. And so there's a great opportunity, and our current Lieutenant General Spellman really talked about that in his 70 by 30 goal, which we had talked about previously. It's particularly the need to value dredged material, that dredged sediment out of our federal navigation channels as a resource, to look for additional opportunities to use it beneficially wherever we can. We've also talked in previous episodes about restoring coastal shorelines and marshes using this dredged material. We also recently did that episode, of the podcast, season 6, episode 9, on the new guidelines for thin layer placement of sediments, a very exciting publication for us in the Army Corps of Engineers. Well, I tell you what, Sarah, that 3D printing lets us take this valuable resource, this sediment, and use it in new and novel ways.
Absolutely, Burton. The Army Corps of Engineers needs novel nature-based solutions for fine-grained sediments to meet these beneficial use goals. Our project delivery team is specifically exploring 3D printing to innovate mission delivery in aquatic ecosystem restoration and flood risk management spaces. We believe that new 3D printing methods that we are developing using locally sourced natural material such as dredged sediment is an innovative new way to create a paradigm shift. The expected outcomes are increased beneficial use options and a public perception shift from dredged sediment as a waste to be dealt with to a valuable resource to be used.
Well, Al, thinking about this resource, what's the opportunity?
3D printing nature-inspired infrastructure and habitat features could unlock new opportunities and benefits. Specifically, this involves design freedom of 3D printing that unlocks the constraints on traditional infrastructure engineering with simple geometric design. We've got bio-inspired design, leveraging natural geometries to address this with the end result of more pleasing recreational uses, improved ecological functionality, and economic and social benefits for years to come. New ideas are popping up every day, such as conformal printing of dredged sediment in place. That's basically a printer that's aware of its surroundings to create features along the contours of local landscapes and even in-place aquatic containment caps.
That's so cool, Al. I mean, there's so many things that we could talk about. I want to move on and talk about the workshop because we talked about some of these ideas. Andrew, talk about the workshop and why it was so important at this point in time.
Yeah, I mean, the concept here is we really wanted to bring together a diverse group of experts from, government, academia, and the private sector, and really get them in the same room for a couple of days here in Vicksburg to explore the potential of 3D printing using natural materials. So this includes dredged sediment, all for these goals of habitat restoration and infrastructure development. So again, we wanted to choose a very diverse group with deep expertise and mix them together kind of organically to see, what ideas and synergies were produced. So we basically set up these think tanks, if you will, with experts where we kind of locked them in a room. But we gave them like sandwiches and coffee. So they were happy. But I think the secret sauce is when we talk to each other across disciplines and when ideas, kind of merge together through those conversations to determine these near-term and long-term feasibility goals as the technology advances.
Yes, we did feed them, but we also made them work pretty hard in the course of the 2 days. Al, talk a little bit about what you were hoping to achieve from a research point of view.
Yeah, and just to echo what Andrew said and expand from it, we really wanted to lay the groundwork to advance practical implementation of 3D printing into nature-inspired infrastructure. We thought the best way to do this was by bringing this diverse group of subject matter experts together from multiple sectors to really build a shared understanding of the potential of this technology beyond our initial thinking. This was initially done by us through lab tours that were led by the ERDC Environmental Lab, the Geotechnical Structures Lab, and the Information Technology Lab to show the diversity of things we have here. And then we led into excellent guest speakers that gave primer thought presentations from Purdue, OnePrint, and Virginia Tech. And they defined the challenges and opportunities for 3D printing nature-inspired infrastructure. We then asked the participants to provide short, medium, and longer-term research ideas and research needs to push this effort forward. All of this would go into a 3D printing nature-inspired infrastructure technology roadmap to clarify both the destination and the path for our end users.
So you had really ambitious goals, and I will say we did have a really ambitious agenda. We had a lot to accomplish in 2 days. Burton, tell us a bit about your thoughts on the participant.
I tell you what, Sarah, it was a very interesting group, and I mean that in a very positive way. Certainly we had colleagues from the Army Corps of Engineers in our engineer research and development laboratories. Plus, we had a range of expertise, ecologists, folks dealing with material science to robotics, artificial intelligence, machine learning, big data, to even landscape architecture, to toxicology. Some of us are toxicologists, classically trained toxicologists. And I would be remiss if I didn't mention our chemical, mechanical, and civil engineers. We also academics, but also some of their students, researchers, and people on the front lines who are working as project managers on infrastructure projects, particularly in marine coastal environments. Some of them came actually from private industry as well. So we had a great mix, I think, of interest and expertise, but we all had that shared passion for potential of using 3D printing, nature-inspired infrastructure.
It was a really energetic group, and I think they were all pretty passionate about what we were talking about. So to explore the potential and begin to develop this research and technology roadmap that Al talked about, we had 4 groups focused on 4 different but synergistic topics. Al, talk a little bit about the 4 groups and why you chose these topics.
Yeah, these 4 group series, you're well aware because you're heavily involved in planning these groups and the directions they should go. These are the 4 major research areas we thought needed acceleration to advance this big idea. In these 4 groups, the first one was ecosystem restoration and bio-inspired design. And that's basically how does ecology drive the design needs for habitat, recolonization, restoration. The second group was coastal resilience and sustainability. And the questions there were what areas need research to develop methods for erosion control or dissipation of storm energy, and how would this be done through structures. The third group was on sediment properties, and the discussion topics there were what materials might be available locally, including dredged sediments, and which ones might have the right properties to be printable and have a resilient structure. And finally, the fourth group was scale up. And the idea is, how do we go from lab scale printing to printing big things on site and on demand to make these big ideas a reality? There was a lot of crosstalk between the groups and more commonalities than I anticipated.
For sure. So, Andrew, your group was focused on the first topic, ecosystem restoration and bio-inspired design. Tell us a little bit about what they talked about.
Yeah, I mean, this was a fun group. We discussed how we can more intentionally design infrastructure to better interact with nature. So we could do this by using nature to tell us how to make improvements through the use of natural materials or natural designs, how to enhance habitat, protect and restore ecosystems. So that was really interesting conversations. We talked about opportunities in really achieving fundamental paradigm shifts of our traditional designs. And so I think that can lead to some really exciting new ideas for co-benefits that we can extract from our built environment. And I think Pablo Zavatiri, who's a professor at civil engineering at Purdue University, said it best.
So we can start thinking about that as engineers. We like to think about really large projects and everything is flat. There is no interaction with life. But now, if we think about it, we can actually start thinking about, what if we put pores in different sizes?
Yeah, and Pablo also had some really interesting perspectives about 3D printing concrete and how we can incorporate even a simple idea of different pore sizes to optimize colonization of critters that we care about, like fish or invertebrates in the aquatic environment.
So now we can actually think about using 3D printing to start looking into pore networks, cavities, vascular systems for life to actually grow. And some of the ideas is that you can try to cover all the landscape, so you have all these cavities, all these tunnels for creatures to go there. But also we can be selective. We can actually have pore size of different, we can avoid certain organisms because they might not be good to be there.
Your group really emphasized that there's so much that we can learn from nature.
Yeah, we talked about how natural systems can build these unbelievably strong, complex, and resilient structures using relatively simple building blocks. And just as an example, honeybees are these amazing engineers. And I think it was Pablo in our group that I thought captured it best, where nature is really just this huge 3D printer, right? Nature can inform how to improve structural integrity of materials, produce, in some cases, truly self-healing materials. So these are all opportunities to improve not only the engineered functionality and resilience, but also truly multifunctional materials, which is extremely exciting, in ways to mimic natural habitat, to better integrate with the natural ecosystem. So this could be, at a minimum, offsetting impacts that we incur from our built infrastructure, or we could drastically improve ecosystem services.
Andrew, I thought your group had some pretty, what I would call, futuristic ideas for bio-inspired 3D printing.
Yeah, they sure did. And listen to just what Pablo has to say about this.
Well, we think a lot of things are going to be improved if we start adding bio-inspiration. We were thinking about self-healing, for example, multifunctionality, adaptability, and diversity. Materials that can move, that can actually make changes when we need them remotely. For large structures, lightweight, big area per unit volumes, or large areas for, to separate waters, semi-permeable membranes. There are many different things that we can actually improve in terms of the structures we build now. Current research right now, what's going on at the lab level, self-healing materials, robot human, AI manufacturing, that's still going on, especially in the construction area. Calcium carbonate used for construction and printing.
Yes, there's so many other applications, as Pablo mentioned. His discussion and the discussion of this group was certainly inspiring, and it really opened our eyes to additional opportunities and possibilities of incorporating bio-inspired design into our own research agenda. These new ideas were beyond our initial thinking and exactly the point of having this interdisciplinary workshop.
There's so much potential. I thought what Jeff Youngblood of Purdue University said was really interesting.
What excites me the most about bio-inspired architecture and bio-derived materials is that nature has spent about 1 billion years optimizing structure. Humans have only been around doing technology for, not 1 billion years. So we get to really learn from nature and how to make better structures. Also, by using bio-derived material, we can lower carbon footprint, we can improve properties, and, hopefully impact humanity.
Wow, that is inspiring. Our second group focused on sediment properties. It was facilitated by our ERDC environmental lab colleague, Mark Ballantyne. The group looked into the characteristics of the materials that could be used for 3D printing. Al, maybe you can talk a little bit about that.
Sure, and I'll do my best to speak for Mark Ballantyne, as I work with him quite a bit, and he's our natural materials printing expert. There was a lot of talking about material feasibility in this breakout group, discussion about what is the optimal particle size distribution, how consistent natural materials, including sediment, dredged sediment, are throughout depths of the harvested material that would be available in the field, and whether the material would have the properties to flow well enough under shear stress to get through a 3D printer nozzle, and then have the ability to rapidly solidify into a structure after printing so it doesn't ooze and lose the aspects that we want from the nature-inspired infrastructure. They also added other criteria to our initial question list, including what are the impacts of natural organic matter and other things that are in the sediments on the printing and the behavior of this material. And there was a great deal of discussion about the need for pre and post-processing the natural materials to meet print parameter requirements.
Yes, Naran Nikalath from Arizona State University presented highlights from the group, including some of the criteria and some of the key challenges that the sediment group discussed.
What time frame are we talking about? Short, medium, long? We simply said it depends on the funding, technology, all of those different factors. How much funding you have, what is the application that you're looking for, what is the maturity of the technology that you're looking to implement, how much risk the owner or the implementer is willing to take. Are there incentives from regulatory standpoint to push these technologies? So all of those will dictate whether it's a short-term, medium-term, or a long-term project. Industry buy-in was one of the things that was repeatedly brought in, because when I say industry, it means the overall owner, whoever owns the final thing. Midterm, we finally decided that for one-off projects, demonstrations, you start research, you figure out how to do it. It could culminate in a demonstration project in about 3 to 5 years. Real deployment in larger situations to actual infrastructure would be a little bit of a long-term goal.
One of the things that resonated with me was the group's comment that incremental improvements lead to disruptive change.
As the group discussed, there was clear issues like larger scale implementation of 3D printing, and getting from the lab scale to the large format printing is going to take time. There's need for research and development and technology transfer, and awaiting the technology maturity to occur, and even potential delays related to permitting of placing natural materials from a 3D printer into the field. The group, I think, along with many of the other groups, heavily discussed the need for materials characterization. There was a lot of discussion about properties and processing properties that's put into a database or a warehouse that could be potentially automated, leveraging artificial intelligence or machine learning to inform the user and the printer alike of the material properties and how the printing needs to be adjusted based on the material that's available. The ultimate goal is to understand the build material that could be produced at a particular location and avoid unintended consequences and potential for structural failures to better ensure the success of the nature-inspired infrastructure.
Yeah, and I thought it was really neat what this group raised about the potential for even 3D printing on site. So if you stop and think about this for a second, this could result in some pretty significant benefits of reducing carbon footprint and reducing transportation costs. I mean, if you could actually 3D print a seawall component as an example, or a reef, using appropriate materials dredged from a local site, I mean, again, that's pretty amazing. So listen to what Nariana had to say about the beneficial use of sediments.
What other options are there that can accelerate the use of these materials into infrastructure that we can quickly do with 3D printing or additive manufacturing? Again, from a feasibility point of view. Skill sets, we'll see the whole laundry list of things that people want to think about, right from fundamental materials chemistry, through material science and engineering, through processing, adding the biology, the biological engineering aspect of it, for processing, the robotics, the data analysis. It's a nice thing about lobbyists, because somebody has to make sure that the people with the big purses can let their purses open to do these things.
Yes, time, money, expertise, and passion are all required to advance the application of 3D printing of nature-inspired infrastructure. And of course, there'll be regulatory hurdles to overcome. But I really liked how Naran wrapped up his group's presentation.
Sustainability benefits, again, whenever you can engineer with nature, when you can design things with nature. We talked about this idea that nature optimizes everything so very well, and when we learn from nature, we also will get an optimized structure. When we start to optimize, it's going to be cheaper and sustainable and much more efficient.
Well said. So my group focused on coastal resilience and sustainability. They were focused on using existing materials, for example, sediment in containment facilities at or near ports. And their vision was to, well, maybe I'll let you listen to what our group's first presenter, Tyler Oates from Rutgers University, had to say.
In the near term, there's lots of low-hanging fruit that we can start looking at. There's existing materials. We can go ahead and get out there and we can say, here's our existing infrastructure. How can we rehabilitate this on-site using some of the well-developed technologies that we have within the 3D printing sphere? And in the long term, as we start thinking about how can we start utilizing dredged material, the long-term ambition being, okay, we have it directly from a barge into a 3D printer into some sort of constructed site. That's obviously, the technologies are completely different right now between the material that you pull out with the high moisture content and the 3D printing demand of a low moisture content.
He went on to describe the work already underway using dredged sediments in different stages of processing, from dewatered to dry, that was obtained from contained disposal facilities.
In the near term, we've already seen with some of the work going on at ERDC, they are 3D printing some of the dried CDF material. Right now, in the dredged community and the coastal resiliency community, there is a need to get rid of our CDFs, so that way we can start storing other stuff. We have dry material that we can start to access now. This material is located in areas where we need coastal resilience. Where you start dredging along coastal shorelines, along riverways, along waterways, those are commonly where we're needing to see shoreline protection berms. We're needing to see other sorts of nature-inspired resources to work with the erosion. So that really spans us the near to the long-term kind of time frame. And from the improvement side, it not only changes the way we're approaching the different designs, the different methodologies, but it also starts to challenge the way we look at what infrastructure protection means, what coastal resiliency is, and really allows us to go for a sustainable design.
I tell you what, Sarah, that comment on how this could really move the needle on sediment beneficial use, I think it would get us closer to the 70 by 30 goal. This effort may be more important, I think, in moving the perception needle rather than the volume needle, because we're really thinking about how dredged material can be used in innovative ways in which it had not been used historically and more conventionally within the Army Corps of Engineers and our partners and stakeholders.
Indeed, I thought it was really interesting that the materials, once they've been classified, are abundant and readily available in existing confined disposal facilities, or CDFs. So back to what Tyler had to say.
We have 40 plus years of material in CDF, dewatered material that can be fed into 3D printing, that can be fed into this sustainability and coastal resilience and kind of make it more of an integrated circular solution, really lowering our environmental footprint while also providing a cheap, often local material source that can be used there.
And what Tyler said is definitely true. And I thought that Wendell Mears' comment from Anchor QEA was interesting. He's doing work with dredged sediments for the Corps of Engineers and now Anchor QEA for over 45 years.
I see us getting into some significant pilot projects. We've got to get out there and blow it up to a size that is meaningful. We're cleaning out some of the CDFs. We're building enough of these components that now we're rebuilding the baseline of our coastal processes. And if we can build something that will support oysters just for 5 years to reestablish a historic reef that we know was there based on mapping, then we've really started rebuilding our coastline. Instead of building from the coast out, we're starting offshore and building in.
Yeah, it's such an exciting opportunity. The potential to use this local availability of sediments for on-site, on-demand 3D printing of nature-inspired infrastructure to advance ecosystem value is so exciting. And I think Wendell realized this. This includes the functional geometric beauty for habitats and created habitats, energy dissipation for coastal resilience, and even new opportunities for carbon and nutrient capture to reduce the prevalence of harmful algal blooms. And we're also looking at the potential to sequester other contaminants that may be in the environment.
My group also talked about success requirements. Tyler Ortego from Natrix spoke about sharing learning, avoiding duplication of effort, and leveraging existing structures and partnerships, including private sector funding. And the need to really leverage these opportunities for advancing 3D printing of these kinds of applications through a community of practice. Here's Tyler.
Community of practice to promote cross-sharing. We need champions in every area of execution, and then bring opportunities to bring other stakeholders, communities to leverage engagement. So if we're doing things with co-benefits and social benefits, it's a great opportunity, but you do have to do the work. So requirements of success, really like the idea of a community of practice. I think a lot of this is going to be driven by people who really care enough to push and to look for those opportunities and make it happen.
Yeah, we sure heard strong support from all of our participants about forming a community of practice. Burton, your group was really focused on scaling up in the next 18 months. What was required? What barriers do we need to overcome?
Indeed, Sarah, that was a really fun group to be a part of. We talked about a lot of topics, but particularly we started talking about what large-scale printing technologies are available and present out there already, and also what are the gaps that may need to be filled. We also talked about logistics, particularly about what would be required to take what is being done at the laboratory scale and actually then translating that to the field scale. What type of equipment that may need to be transported to the job site, for example, to do 3D printing in situ, very, very close to where the dredged material is being removed in the Federal Navigation Channel. We also discussed how we can get enough of the right dredged material, whether it be sandy or perhaps more fine-grained, where we need it the most, and how we can deal with the expense of pre- and post-processing it. That would depend on, of course, again, whether we're dealing with sandy material where we need sand particles in our formulations, or whether we need fine-grained materials and particles. And of course, we need to talk a lot about the current regulations and the permitting process and what may need to be accomplished there, and what would be required to do scaled up 3D printing in the field.
Your group gave us a lot to think about, Bert. And one of the things I thought was really interesting was your group's emphasis on the need and the opportunity to do this work at the job site. Abby Lloyd, who works for Ashgrove Concrete and presented for your team, was pretty passionate about the need and the safety benefits of doing so.
From a personal aspect, I just want to make sure everyone knows that this technology, if it's used in the right way in the construction industry, will save lives.
This was a fantastic added benefit I would not have thought of. Improved safety on the job site due to remote 3D printing, automation, or operations wasn't on my radar. This could be a significant benefit of scaled up 3D printing on site. Just listen to Abby's perspective on construction sites.
You've got at least 20 guys there, or girls, and they are working their asses off, and it's dangerous, whatever situation you're in. And if we can automate it, whether it's through 3D printing or adapting the already construction equipment that we have on site, not only are we making it better in terms of probably the durability, the sustainability, but also for the safety and the culture of everyone in construction sites.
From the safety perspective, it's so important for us and relevant to the Army Corps of Engineers with our recent emphasis and reminding us about our safety objectives while executing our civil works missions. Abby also spoke to some of the challenges of 3D printing on the site, and I thought her group's discussion on software was particularly intriguing.
This is going to be probably really complicated with structures are all different. If you're going to be working on different parts of the coastline as well, then, does one size fit all? Is it going to be different? You're going to have different geologies. You're going to have different water. It's going to be everything. So software is going to have to counter for that as well.
Burton, there's some good food for thought here for the research agenda.
Indeed, there are. The group gave us a lot of ideas for our research agenda going forward for this particular research task in engineering with nature. Thinking about scaling up, our group talked about everything from nozzle design to characterizing the dredged material that is available to us for 3D printing applications, to volumes of dredged material available for printing, and so on and so forth. Then we talked about implications for the actual printing itself, including dewatering the dredged material so as a sufficient quantity, but particularly quality, that is available to be used effectively for 3D printing. We also recognized it was important to recognize large-scale cement printing is also occurring in other sectors. So one of our desired workshop outcomes includes this community of practice. Take advantage, innovate use of natural materials, including sediments, as the feedstock for large-scale printing, whether they be sandy particles or even fine-grained particles. In fact, one print was so interested in the concept, they had us send them their sea hive design printed with dredged sediment for a recent engagement.
That is so cool, especially that you were able to print the sea hive at the lab using both clay and dredged material from Mobile Harbor. Listen to what Adam Freeman, CEO of OnePrint, had to say.
The EWN 3D printing conference that we attended was a huge eye-opener for us in what the U.S. Army Corps of Engineers and ERDC and EWN's initiatives are for the next few years. And the biggest eye-opener was the use of dredged material in 3D printing. And this is something that within our network of partners, strategic partners, we believe that this can be put into a, say, 3 to 5, 10-year plan with realistic, achievable goals to support the initiatives of ERDC and engineering with nature. We were attending a climate conference called Aspen Ideas Climate 2024 in Miami. And we said, leading up to that, it would be a great opportunity to showcase this dredged material in one way or another. We know that we can't do it on a large scale just yet, even though we're hoping to work towards that. But touring the lab with Alan and Mark and Burton and Andrew and all the great things that they're doing over there, we did see that they were doing it on a small scale. So we said, hey, let's really put our foot on the gas pedal here and let's get a sea hive, some IP that we support from the University of Miami. And even if it's a small scale, at least it's a start. And let's put that on our desk at our expo. And I will tell you that the dredged material sea hive that the team over there at ERDC was able to print out on their small scale printer was the most talked about item at our expo booth.
Tell us about that. What were people excited about, Adam?
First of all, what the ERDC and the folks over there, what they're doing is just so extraordinary and groundbreaking that people haven't even thought of doing this before, right? Using dredged material. But then when you use dredged material to 3D print, now their heads are spinning. And then to see it right there in front of them and actually able to pick it up and say, wait a minute, this is dredged material, and wait a minute, this is 3D printed. That's when, things started clicking. And again, thank you very much to Alan and Mark and Burton and Andrew for getting that over to us in such a tight timeline, but it arrived just in time. And people were amazed by it. Remember, this is many technologies that we're forming in one, whether it's the 3D printing technology, whether it's the dredged material technology, and also the sea hive technology. These are all very high-tech components all converging in one product, potentially.
So, Andrew, there was such great output from all four of the groups and really all of our participants.
Yeah, I agree. I mean, we learned a ton. And some of the key themes that we took away was we really have an opportunity here to categorize materials and feedstocks that could be used for specific 3D print applications. And this could really move us a lot closer to these future goals, right? So linking these feedstock resources like dredged sediment, identifying spec sheets, and providing that to the additive manufacturing world is really a next step. And it really allows us to start breaking down these technology silos, right? Of we need to start communicating with the additive manufacturing world, what those specific characteristics are of dredge sediment as an example. And another common theme that came out from the group is we really need to get to larger field scale demonstrations. And in those demonstrations, really have the opportunity to fail. And interestingly, failure is often our greatest teacher, and it's a mechanism that helps us advance science and technology. So we really need more opportunities to do these scale demonstrations to test these ideas.
I agree. Failure is the key to innovation. So, Al, one of the common themes that we heard throughout the workshop was the need for collaboration, multidisciplinary collaboration. Can you speak to that?
For sure, Sarah. And a primary workshop objective was to test the waters to see if there would be interest in forming this community of practice around 3D printing of nature-inspired infrastructure using natural materials. And so clearly there was. I'm still fielding emails, setting up future meetings. We're building a listserv now, and we want to encourage people beyond the February workshop participants to get in touch if they're interested in being part of this new group.
Oh, that's just great, Al. And certainly there was a lot of support and a lot of enthusiasm about having a community of practice. We'll make sure we include information about how to get involved in our show notes. And I hope we get a lot of interest from people with all different kinds of expertise.
Yeah, and building this community of practice is so important to drive innovation, especially for introverts like me. It really forced me into the process. I tend to naturally silo myself into my comfort zone, focusing on tools and ideas that I'm most comfortable with. These types of engagement are critical for us to take the next steps because we can't figure all of this out on our own.
Hey, I agree, Al. In addition to that, through the community of practice, it gives us other opportunities. I think we look for short-term opportunities to engage as subject matter experts in this field, particularly looking for opportunities to engage at upcoming conferences, creating an email listserv, and simply promoting and talking about these ideas broadly. Let's take advantage of all the good information that was shared during the workshop and use that as a springboard to continue our engagements going forward. And, for example, starting with this podcast here today.
Well, thanks, Burton. And I agree. There was so much interest, so much enthusiasm. We want to keep that momentum going. There's a lot of work ahead for the team and certainly for the community of practice to work on. We thought it would be really interesting to wrap up this episode by listening to what some of our workshop participants are working on in the near future. Chris Williams is a professor in the Department of Mechanical Engineering at Virginia Tech, where he directs a research lab focused on additive manufacturing processes and materials.
My research is mainly focused on creating new 3D printing technologies. So one thing that we're really excited about is working with robotic arms. They provide us an opportunity to truly 3D print, no longer printing layer by layer like in two-dimensional forms, but actually truly articulating the arm and actually printing materials out of plane. And we do that because we think it provides us an opportunity to architect the material and the performance in a better way. What I really like about its opportunity to influence or connect with engineering with nature principles is it provides us a way to do on-site fabrication and actually allows us to actually print material onto existing infrastructure. So I really like this opportunity in Engineering with Nature program to think about how we can add to existing infrastructure, not only repair it, but actually make it more compatible with the nature around us. And I think that's a tremendous opportunity to combine those expertise together.
Daniel Wong-Pressert is a researcher at the Department of Nanoengineering at Scripps Institution of Oceanography at UC San Diego.
Right now, we're working on developing hybrid coral reefs for coastal protection, but these systems should be multifunctional. So not only should you develop an infrastructure that attenuates wave energy, but at the same time enhance biodiversity, be resilient to climate change, and so on. So this requires different manufacturing approaches that traditional techniques can't provide. So my research primarily uses 3D bioprinting approaches structures, which means we're basically 3D printing living materials. And right now what we're doing is to focus on the recruitment of biological organisms to these hybrid reef structures. So as an example, we're 3D bioprinting bacterial communities that can enhance the recruitment of coral larvae to these structures in order to kickstart ecosystem processes mimicking natural coral reefs.
And our colleague, Lucy Slattery, is an engineer at the Geotechnical Structures Lab at ERDC. She's doing some just amazing work.
So I work in large format thermoplastic, and we have a couple of barriers that we're facing right now. And the workshop kind of helped us pinpoint some of those. So the big one is that we need to come up with ways to characterize the materials that we're using. So that was a really big piece of the workshop that we talked about how can we characterize this material and determine what we can actually print with versus what we kind of need to just treat as waste, and how do we approach that problem. And that's not just in the case of like dredging material, but that's also with all of the materials that we work with. Like all industries are trying to come up with some sort of standardization for that material. Another really big barrier is process control. So a lot of people that have 3D printers at home have had prints fail, and they can't tell you exactly why. And they run it a second time and it's super successful, and you don't really know the difference between those different prints. So what we're working towards is how can we come up with a scientific and research-based approach to control that process so that we do know what's causing those failures and we can predict them before they happen. So one of the ways that we're doing that is a database that's called the Material Process Property Warehouse. And that's been developed with ERDC and also the University of Maine. And we're trying to launch it as a data collection database of where we can kind of track all of these processes that we're doing and the resultant material properties that come out of it, and create this giant map of information and then use that to create models that can predict issues with parts before they start to fail.
So that's going to be of huge benefit to ERDC, but it's also going to be a huge benefit to the new community of practice.
Yeah, so we're using some industry as guinea pigs to give us feedback on it so that we can make it better before it gets launched. I believe it's DoD wide, and then ideally academics as well, because the more people that participate, ideally the whole community of practice, the more data sets we get and the bigger picture we can build about how can we control the process of additive manufacturing so that everyone gets warm and fuzzy feelings about printing.
So that's really going to advance 3D printing with nature-inspired materials.
Yeah, because it provides more confidence in how we actually approach these problems. And it's across the board additive manufacturing, but bio-inspired, I see it being really, really significant because we're already trying to push the bounds with implementing an additive construction form. And we're pushing the bounds geometrically to try and make these bio-inspired shapes. And we're pushing the bounds materially because we're trying to use a material that hasn't been used for any, I don't know a ton about dredging material, but it hasn't been used in the ways we're trying to use it. So the more confidence we can provide in this technology, the more likely it is to really be able to take hold and provide the benefits that we all want to see.
Beautiful. Well, that's a wrap. Thank you to all of our workshop participants for a really stimulating 2 days. And special thanks to all of those who joined us on this podcast. Al, Burton, Andrew, thank you all for sharing the incredible work to date that you and your colleagues have been doing on 3D printing of nature-inspired infrastructure and for giving us a glimpse of this future that's just before us. I can't wait to see how this technology evolves.
Yeah, Sarah, and I'm personally very enthusiastic about this topic, and I kind of nerd out about the potential for 3D printing. When I first saw it demonstrated years ago, I walked away with one thought, and that thought was, hey, we're living in the future. And what I learned at this workshop, that these technologies are here and they're advancing at a crazy rapid pace. So it just screams opportunities to innovate our built environment.
Those are great thoughts, Andrew. Thinking about the built environment And what we're really doing here is really exploring the nexus between that built environment. It's the engineering of that infrastructure and looking at the nexus between that and natural resources in the form of dredged sediment, and also looking and taking advantage of natural processes, the ways in which we can apply 3D printed materials in the natural environment gives us a tremendous amount of opportunities and a tremendous upside going forward. Not only thinking about increasing the beneficial use of dredge material, but the opportunities for us to touch on those concepts of improving resiliency, not only to the infrastructure itself, but also improving the community resiliency. The communities that are going to be relying on this infrastructure to reduce coastal storm risk and flood risk in the future.
This engagement was certainly a lot of work and daunting going into it, but it was certainly fun and definitely worthwhile in the end. I hope that we adequately expressed our excitement about the potential benefits of this disruptive technology for the Army Corps of Engineers and the nation and the world. I need to echo what Burton said, that we're excited about increased beneficial use options and on-demand construction with locally used materials that are just available to reduce transportation costs, and the opportunity to have this public perception shift about what dredged material or dredged sediment is and how it can be used to create nature-based features to reduce coastal infrastructure damage nationwide and perhaps worldwide. We're excited, stimulated, and focused in our respective ERDC laboratories on creating a different and better future with nature-inspired 3D printed materials. Stay tuned.
Hey, we'll definitely be keeping a close watch, Al, and we'll be keeping our Engineering with Nature podcast listeners informed as 3D printing evolves. And to all of you, thank you so much for listening. We hope you've enjoyed this podcast, and we hope you'll join us again as we talk about engineering with nature.
You've been listening to the EWN podcast, developed by Sarah Thorne and Jeff King, National Lead, Engineering with Nature Initiative, U.S. Army Corps of Engineers. Now, for more information, you can visit our website, engineeringwithnature.org. The EWN podcast is produced by Eye Contact Productions for the Engineering with Nature program within the U.S. Army Corps of Engineers. I'm Dave Trafford.